All right, so we are going to have a continuation. We're still there. So you're just gonna be patient with me, because we're still there. But like I said, make sure that you do watch from the introduction up to the end of these videos for transformation, so that you'll be able to understand each and every part that you are going to be given in your examinations. So this is a continuation from our translation. We still want to add some information. We still need to add some knowledge, yeah, to our understanding. So let me try to explain the other part. Remember, we talked about the describing of the translation from this previous video, where I had this part here. Remember, I referred that a translation, before you describe it, before we describe that this is a translation, we will need this condition of the object and the image being congruent. Then when you join the corresponding points, you are going to have parallel lines of equal length. Then we did an example there. If you still remember, we had an example. So if you never watched that, make sure that you do so, because this is a continuation. So we are given this time, we are going to just start from there. Then we continue from the condition, where they can even give you the object and the translation vector. Then you'll be asked to draw the image. So that will be the major part of this class. But we still, we're still gonna need to start with the describing part. Then we are given a question, draw triangle ABC. We are given triangle ABC with these vertices, so we need to draw it. Also triangle A1, B1, C1 with the vertices, these ones, we need also to draw these. So you'll be given a certain scale to use 2 centimeters, maybe to represent 1 unit on both axes. So this is what I'm going to apply on this one. So I've got 1, 2, 3, 4, 5, just like the previous case, -1, -2, -3, -4, -5. So you're gonna just indicate your Cartesian plan properly. All right. Just gonna indicate our Cartesian plan properly. So this is what you're gonna have. Okay, something like this: 1, 2, 3, 4, 5, and so on. So up to 6, like this. So this is what you have there. So we are given 2 triangles there. The first triangle being ABC, with A -3, -3, B -4, -4, and C -2, -4. So let us mark this triangle first. The triangle ABC, we are given that A is -3, -3. So X is -3, Y is -3. So -3, -3, they do meet at this point. So that is where our A is. So I'm just going to name this A. So I write A aside, not on this point A there, no, just aside the point, okay? Then the point B was given as -4, -4, meaning to say X is -4, Y is -4. Where these two meet, X is -4, Y is -4, they meet somewhere there. You mark a point where these two meet. That's our point B. The point C was given as -2, -4, where X is -2 and Y is -4. They do meet at this point. Where they meet, you mark a point. That's your point C. So with this, we are going to draw our triangle, just like the previous case that we had ended up drawing, marking our triangle from A to B. We're going to have from A to B, then also from B to C. All right, then also you're going to have this from A to C, something like that. Okay, that's your triangle ABC. Then we move on to the other one that you're given, which is the other triangle A1, B1, C1 with the vertices A1, B1, C1 like that. A1, 0, 1, B1, -1, and -1, 0, and C1, 1, 0. So you're going to mark these points just like the previous case that we had. So we've got the first point, 0 versus 1. That's X is a 0. then y is a 1. That's 0 versus 1. So we're going to name this point A1. B1 was at -1, 0. That's -1, 0 somewhere there. This is our point B1. Then the point C1, which is at 1, 0. So you mark 1, 0 there. That's our point C1. So these are the points that are building or making up our triangle A1, B1, C1. So what you just need is to join the points that you are given on this part. All right, so you're gonna need to join from this to this one, then from this one to this one, like this. So you've got triangle A1, B1, C1. A1, B1, C1. That's a triangle that you formed there. So that's a mark. Just to draw this triangle, that's a mark. To draw this triangle, that's a mark. Just to draw, that's a mark. So the question is, now that we have drawn this triangle, the question is describe. We need to describe now the transformation, which is the single transformation. That is one transformation, which maps now triangle ABC onto this. So this ABC is the object. Onto is the image. Onto this A1, B1, C1, which is our image. So meaning to say, triangle ABC, this one is our object. So like I said, you need to realize the relationship between the object and the image. What is the relationship between these two? Is the object and the image, are they of the same size? Is it the same shape? Still we have the same triangle, same size. These guys, by just looking you can see that these two triangles, they are congruent. My sight saves me where there. These two triangles, guys, they are exactly the same. They are congruent figures. So I say that if they are congruent figures, we are going to have these three transformations in mind: a translation, a rotation, a reflection, and a rotation. These are the three transformations that we are going to have in mind before we conclude to say it is a. We need the transformations in mind. These three, the ones that are for isometries, when the figures are congruent. Remember, I said these three transformations on our introduction are from congruent. They are from congruent what? Congruent figures. So knowing that these two figures are congruent, now we have to join our points, corresponding points, so that we conclude now the transformation. Now we want to conclude. So you join from A to A1 using broken lines. You've joined A to A1. You do the same thing, B to B1 like this, C to C1 like this. This is what you join. All right? A to A1, B to B1. But just looking, guys, the distance between these two lines that are here, these ones here, the distance in between, the distance in between is the same. We are maintaining same distance, meaning to say these two lines are parallel. Here, between these two lines also, this is parallel. So you see this line and this line, they are parallel. They will never meet. Parallel means they will never meet. No, join, guys, extend these lines further. You see that these lines, they will never meet. They are parallel. So once they are parallel, you do not conclude to say now it is a transformation like this one. No, because we must know about the length. Are they of equal length? If they are of equal length, then we can conclude that it is a translation. So we have to measure the length. By just looking, guys, we can see this is equal length from C to C1, from A to A1, from B to B1. This is equal length. Or I said you can just use your divider to check also. You can just have your divider. So in this case, I just have this one. Just gonna use this. So this is what I'm going to do. I open the size, let's say from A to A1. Okay, I'm just gonna open a certain size regarding the diagram. So I'm gonna open from point A to point A1 like this. This is the distance that I'm having from A to A1. You see, this distance that I'm having here from A to A1 must be the same throughout. So if I put this through C and C1, look, C to C1 is the same. B to B1, here, this is our B and B1, it's the same. So it's same distance, meaning to say these parallel lines are of equal length. So we say that if the parallel lines are of equal length, which transformation is it now? Because now you have to conclude, because you saw that these two figures are congruent, then you are saying it can be a translation, it can be a rotation, it can be a reflection. You were having three answers. But when you joined A to A1, B to B1, C to C1, you produced parallel lines of equal length. Which type of transformation is that? Remember, that is a translation. So you now describe it is a translation. Not to say it is a transformation. No, it is a translation. The type of transformation is the one that you are describing. It is a translation. It is only a translation that will produce parallel lines of equal length when corresponding points are being joined, when the two figures are congruent. There is no other transformation that is going to do something like that. It is only a translation. But remember, when you are describing a translation fully, you need its translation vector, where we said it's the image minus the object. So we are going to also need the translation vector. So translation vector, we said this is the image minus the object point, where you can even take it as a point. The image, remember, triangle A1, B1, C1 is our image triangle. The transformation which maps triangle ABC onto this. So it means ABC is the A1, B1, C1. This one is the image. So we are going to take corresponding points. We subtract image minus object. So image, if I use A1 on the image, I'm going to use A on the object. So this is A1, the point A1, the coordinates. So if you are confused about these coordinates, go back to here, because go back to these points here. A1, the point there, that's 0, 1. But you just have to write it as a column vector. So that's 0, 1 like this, minus the point A also as a column vector. The point A is given as minus 3, minus 3. So you take the corresponding points. They must be corresponding. So by subtracting this, 0 minus minus 3, that's a positive 4. 1 minus minus 3, that's a positive 4. So meaning to say our, 0 minus, guys, you see this? That's a 3 there, okay? 0 minus minus, I'm taking now as a 1 there, that's a 0 there. Then 1 minus minus, that's a positive 4. So that's your translation vector. Image minus object. So this is to describe a translation fully. So to write this, that's a mark. To write the translation vector, that's a mark. Already, there is a mark to draw the object, a mark to draw the image. So we've got 4 marks. On a question on a transformation only, there's 4 marks there. So this is what you can do on this vector. Remember, you can use any point, B1 minus B, it's up to you. You can use any condition. Let's just prove with one, last one, C1 minus C. C1, it was 1, 0, minus C, it was minus 2, minus 4, minus 2, minus 4. 1 minus minus 2, that's 1 plus 2, which is 3. That's a 0 there, minus minus 4, that's a plus 4, 3, 4. So as you can see, any combination that you choose, it must give you the same translation vector as long you are subtracting correspondingly C1 to C, B1 to B. You are subtracting corresponding points, but as a vector, you must have the same answer. Now let me describe this translation vector in full. What is a vector? Consider this, guys. You did your vectors in vector 1. Okay, here we are done on this question. I just want you to see what a vector means. A vector, we said, it's a movement. Whenever you consider a vector, that's a movement which have taken place. But this movement is not just a normal movement. It's a movement that you consider in terms of the x and in terms of the y. Okay, this is it, guys. We are on the Cartesian plane here, so we can understand this much better. On a Cartesian plane, if you are moving towards the x, towards the right side of the x-axis, you are moving in the x to the right. You are moving to the right side. That's to the positive side. So any movement that you are going to make to the right side of the x-axis, that movement is going to be positive. Any movement that you're going to move to the left side of the x-axis, that movement is going to be taken as a negative, which is the same thing as the movement along the y-axis. Any movement that you're going to take vertically up along the y-axis, it is going to be taken as a positive. Any movement downwards is going to be taken as a negative. So with this idea, let us try to see how can we determine the translation vector, not by calculation, but by movement, because a vector is a movement. So a translation vector also can be determined by movement. You can determine it by movement. So if it represents a movement in x and a movement in y, I simply have to ask myself, how am I going to move from point A to point A1? How? I have to move in x, then y. So this is where A is, guys. This is it. Here, we need to move from this point A to point A1. That is a vector. So we must move along the x until we reach where we see the A1 is. This is where we see our A1. So we have to move along until we can see our A1 to say, okay, at this point, if I move up, I'm going to reach A1. Remember, I said it's a movement in x. So you start with x, then y. So at this point, you can see that if I move up, I'm going to meet the point at what? At A1. Not to say you are going to extend at this point, then you expect to meet A1. How? It's impossible. So as you are moving along the x-axis, you must move to a condition where you see the A1. You can't move from A to this position, because if you move up, you are not going to meet A1. So it's impossible. So you have to move until you can properly say, okay, at this point, if I move up, I'm going to reach point A1. You don't need to indicate this. No, maybe you can just use your broken lines like this. Okay, let's just do something like this. Let's just do something like this. From A straight up with a straight in the horizontal with a vertical line. Okay, horizontal line straight in the horizontal line, straight in the horizontal. It's a movement in the x. The x-axis is a horizontal line. You don't move like this. So you're moving in the no. You move along the horizontal, then to the point up. So we are going to move from this point up to A1 there. So this is the movement. So we are saying a vector is a movement. You moved from A along the x, along the horizontal, to a point where you can see, okay, at this point, I can properly see my point A1. Then you move up until you meet the point A1 at this point. So this movement, how can we express it? That is a translation vector to say, in terms of x, how many units? How many units? We moved how many units in x? How many units from A to this point? How many units? Let's count. 1, 2, 3. A box, a box, a box. 3 units. So you count like this from A. That's 1, 2, 3. We moved 3 units. 3 according to scale. According to our scale, each box represents 1 unit. So you consider that according to the scale. So according to scale, that is 1, 2, 3. But which side are we moving to? Which side? We are moving to the right side. I said any movement that you are going to make to the right side in the horizontal is a positive. So meaning to say the movement in the x that we start with, it's positive 3. 1, 2, 3 up to this point. So we moved 3 units up to this point. Then you move, because you're supposed to move also in the y. But where are we going? We need to reach the point A1 here. So are we going to move down from this point? Are we going to move this side? No. We must move up to reach where A1 is. So we're going to move how many units now to A? 1, 2, 3, 4 units according to scale. From this point, 1, you move from, that's 1, 2, 3, 4. 4 units according to scale. Going where? We are going up. So anything about the y as it is going up, it is considered what? As a positive. It's a positive. So meaning to say these are 4 units going up, that is positive 4. That's the translation vector. So a translation vector can be given also from movement, which is the same thing that we obtained here by calculation when we used the formula for the translation vector being taken as the image minus the object point. So you can do that by calculation or by movement. Okay, let's try again. Let's try by movement from B to B1. So by movement, you must move from the object to the image. You are moving from where the point is to where it is now situated. That is, but you have to be careful when it comes to by movement now. Okay, let's consider from B to B1. We are going to move from B. Which side? Are we going this side in the X? No. Look where B1 is. We can't go this side. We have to move to the right side. So we are going to move up to this point where we can properly see. At this point, we are at the point where B1 is situated. The point B1 here. We can go up from that point here, going up to B1. That's it at this point. So this is the movement that you're going to take. From B up to this point, then you go up. Horizontally, then vertically. X, then Y. So the movement in X, how many units from B? 1, a box, 2, 3. So we moved 3 boxes according to scale. Each box is 1 unit. We are going which side? To the right, so it's a positive 3. When you are at this point, how many units to where B1 is? How many units? 1, 2, 3, 4. 4 units. So as we can see, each movement as it is made, it is making up a right angle from the point to the image. You must make a right angle, not to say your movement is like this. That is not supposed to happen. So it can be like this. It can be like this. You move in the X, then you move down in the Y, forming a right angle. You can move to the negative, then you can go up. It depends with where the point is from object to image. So I want you to try by movement from C up to C1 and see if you're going to have the same answer, which is 3, 4. So we saw that the translation vector the translation vector is not only from a calculation, it can be determined from a movement. It can be a movement in X, a movement in Y. How many units in X? How many units in Y? From the corresponding A to A1. If you work with C to C1, not to join C and B1, no. C is supposed to correspond straight to where the C1 is. How many units? 1, 2, 3. How many units up? 1, 2, 3, 4. So that's your transformation on a translation. All right. So as we saw that this can be determined, that we can have a condition where the object and image are given, then you're asked to describe. So you are going to opt, when it comes to the calculation now of the translation vector, to the determination of the translation vector, you are going to choose to use the calculation or to work by a movement, to determine that by a movement. All right, so I want you to try these two questions. Then we're going to talk about it on the comment section on your answers that you're going to have. Make sure that you write your answers. Just write the answers. It is at this. Then also you write the translation vector so that we see if we are together. So on each part, you are going to describe the single transformation. Describe the single transformation which maps. All right. So on each case, you are going to describe the single transformation which maps triangle ABC onto triangle A1, B1, C1. All right. So the first one, we have got triangle ABC with vertices A, 2, 2, B, 1, 2, and C given as 2, 3. So these are the vertices of the triangle ABC. And triangle A1, B1, C1 has got vertices A1. Remember, you need to draw first. So you're going to draw these. So triangle A1, B1, C1 has got vertices A1, 1 minus 1, B1, 0 minus 1, and C1 is given as 1, 0. All right. So I want you to describe the transformation, the single transformation, which will map ABC onto triangle A1, B1, C1. So you need to draw these two triangles. All right. So that's your first question. Then the second one, again, you are going to draw this. So use the scale 2 centimeters to represent 1 unit on both axes. So use scale 2 centimeters to represent 1 unit on both axes. On both axes. That is on both axes, X and Y. All right, so that's your first question. The second question, I want you to do the same thing, but this time your triangle ABC is going to be given these coordinates with A, 2 minus 3. Okay, B, 2 minus 5. And C, 0 minus 5. All right. And the image one, which is triangle A1, B1, C1. So we've got triangle A1, B1, C1, where A1 is given as 2, 1. The point B1 is given as 2 minus 1. And C1 is given as 0 minus 1. All right, that's 0 minus 1. That's the point C1. Okay, so what you're going to do this is a question on its own, question number 1, but the question is the same. You describe the single transformation which maps what? Triangle ABC onto triangle A1, B1, C1. But there are 2 questions. So this is the first question. You draw your object and image. You describe your transformation. You do another question. You draw this one. You describe that transformation. So make sure that you do the proper thing so that we see if we are on the same page. We need to see if we are on the same page. Try this one. Make sure you do try that, and you write your answers on the comment section so that you'll be able to know if we are together. So this is the first part of your translation. This is the first part of your translation. We are going to have another part of our translation. I mean, this is the second part actually of our translation, like when you are considering the movement of that vector. So we're going to have another part when you now draw the image given the translation vector and object. That will be our next class. So I'm hoping these classes, they are helpful. If they are helpful, don't forget to drop a comment section so that that can help us to know what you need to understand or the topics that you need me to work on. Make sure that you do that to drop the comments, to drop your topic on the comment section. This can help me to know which part exactly that you need me to explain. I might assume that you understand everything, while there is an area that you do not know. So let me know.